1,034 feet long and 213 feet tall, MSC Bellissima is one of the largest cruise ships on the planet. This Leviathan carries over 5,500 guests to destinations all across Europe.
It's a self-sufficient city which has to be comfortable for the passengers.
How did engineers build a cruise ship this big? And what innovations keep it sailing all year round?
Cruise ships today are absolutely engineering marvels.
We unlock the secrets that help this vessel deliver a super smooth ride. From ingenious stabilizers that keep the ship level in the roughest seas, to near silent propellers that thrust it fast through the water, to reveal what it takes to build the ultimate mega cruise ship. The Mediterranean coast. Tourists from around the world flock to these spectacular shores to soak up the area's rich history, culture, and sunshine. Each year, over 3 million of them choose to take it all in, from the comfort of a luxury mega cruise ship. 12 cruise operators, running a total of 40 supersized vessels, compete for a slice of the $60 billion Mediterranean vacation industry. Passengers looking for a once-in-a-lifetime experience expect 5-star service, spacious outdoor areas with the finest amenities, and an itinerary full of stops in spectacular locations. To corner the market, operator MSC Cruises built this extraordinary cruise ship, MSC Bellissima. At 1,034 feet long, 141 feet wide, and 19 decks high, this is MSC's biggest ship. The innovative engineering hidden inside Bellissima's mighty frame helps give passengers the ultimate cruise experience. A unique hull design allows it to glide into shallow European ports. Superfine membranes filter molecule-sized particles to turn the salty sea into pure drinking water. An ingenious scrubber system cleans noxious chemicals from exhaust released above the deck. All of these elements combine to make MSC Bellissima the ultimate cruise ship. (11 a.m., Barcelona, Spain. Bellissima opens its gangways and welcomes passengers on board. Immigration purser Alfonso Gargiulo has 6 hours to get all of them onto the ship.
MSC Bellissima is almost fully booked. We have on board about 5,600 guests. This is the most critical moment for us.
Across the ship, the 1,500-person crew completes final preparations before the vessel departs for its 7-night voyage, which will include stops in 6 iconic Mediterranean cities. From the port of Barcelona, Bellissima will head northeast along the Spanish and French coasts. First stop, Marseille. The voyage continues into Italian waters, stopping next in Genoa to pick up vital supplies. From here, the ship will head southeast, stopping at Naples and Messina. The ship will then call into Valletta, Malta, before it makes the 747-mile trip back to Barcelona. Bellissima is double the size of a traditional liner and carries 3 times as many passengers. Building a ship this big with a draft shallow enough to enter the most popular Mediterranean ports is a huge engineering challenge. A ship's draft is the distance between the bottom of its keel and the waterline. The more load a ship carries, the deeper its draft becomes. A large traditional liner carries 2,000 passengers throughout 12 decks and has a 28-foot draft, shallow enough to enter most harbors. But today's mega cruise ships need extra decks to entertain thousands more passengers than the largest classic liners. Adding this extra weight to a standard liner design would make its draft so deep that the ship could run aground in port. Shipbuilder Chantiers de l'Atlantique came up with a solution when they designed and built Bellissima in 2016. The engineers at this facility in France weld over 1,100 tons of steel every week to construct MSC's fleet of mega cruise ships. Design manager Guillaume Legris has to balance every new vessel's size with its need for a shallow draft.
The first discussion we have when we design such a ship is to define the ports where the ship will go, and this will give us the main dimension of the ship.
Guillaume sculpted Bellissima's hull to make the supersized cruise ship float higher in the water. A ship floats higher and reduces its draft when it spreads its weight over a larger area. Guillaume's team takes a traditional hull shape and stretches it longer and pulls the beam wider to 141 feet, increasing the area of its hull in contact with water. The team also flattens the keel for extra clearance over marine obstacles. This ingenious design means Bellissima should glide into most ports with no danger of running aground. But this innovative design is just one part of the solution. Classic liners were constructed from thick steel plates riveted together, which made them strong, but also very heavy. Building Bellissima's huge structure using these traditional techniques and materials would cancel out the benefits of the ship's hull redesign. Any vessel still risks grounding if it weighs too much. At the shipyard, engineers use an innovative construction method to keep the frames of ships, like Bellissima, as light as possible. They build ships by welding together boxes made out of lightweight sheet steel. Project manager Elise Guérin oversees the operation.
For a steel engineer, it's quite a challenge. There are more than 300,000 parts which have to be welded together to form the ship.
To make Bellissima's deck, robots welded together large sheets of steel, each less than 10 millimeters thick. Workers welded on metal plates called stiffeners to strengthen the decks. Next, computer-controlled plasma cutting machines sliced more steel to make the deck's walls. A team of welders joined these wall pieces to the decks to make a giant reinforced hull section. They joined together an average of 12 hull sections to build a mega block. This super huge ship section is 141 feet wide and 33 feet tall and weighs more than 1,100 tons. Elise's team used one of the most powerful gantry cranes in Europe to lift and place each of the 50 mega blocks that make up Bellissima.
Fitting a block is a big challenge. You've got a very small tolerance in order to be able to adjust the block to the ship. Every day, we fit a new block. It's amazing.
It took Elise's team around 18 months to turn over 38,000 tons of steel into the finished Bellissima. Mega blocks make it possible for engineers to build a vessel that weighs almost the same as a traditional liner, but is double the size. Constructing Bellissima from thin but tough steel keeps the ship's 7,000 passengers and crew high in the water and prevents the ship from running aground in port. In Barcelona, the dockside crew releases Bellissima's mooring lines, and the ship's huge engines thrust it out of port. The 8-day Mediterranean voyage begins. What ingenious technology makes the propellers on this mighty ship near silent? And how does it create over 3 million gallons of drinking water out of the salty sea? As day one of its 8-day voyage comes to an end, cruise ship MSC Bellissima powers across the Mediterranean Sea towards the city of Marseille on the French coast. Most of the 5,600 passengers on board spend the evening in one of the ship's 32 bars and restaurants, or in one of the vessel's 2 theaters spinning propellers. The faster a propeller rotates, the more thrust it produces. An area of low pressure forms in front of each propeller blade as it slices through the water. The pressure is so low, the water boils, creating thousands of tiny steam-filled bubbles on the surface of the blades. These bubbles pop, a phenomenon called cavitation. One tiny bubble pop on its own doesn't matter, but thousands popping simultaneously can send powerful, noisy vibrations throughout the entire ship. To ensure Bellissima's passengers get a good night's sleep, hydrodynamic engineer Loic Morand had to come up with a way to eliminate cavitation noise.
Cavitation is like a hammer which impacts a steel plate. It's very, very noisy and it's very disturbing. So we have to avoid these situations on the cruise ship, that's for sure.
Many traditional propellers have 3 blades. Their fast rotation generates huge thrust to push a ship forwards. But the propeller's fast-turning speed creates noisy cavitation. One solution is to slow the propeller's rotation, which will generate fewer bubbles and cut cavitation noise. But slow propellers will reduce a ship's thrust. To bring the ship back up to speed, Loic's team adds 2 extra blades to each of the ship's 2 propellers. Having 5 blades increases the propeller's surface area pushing against the water. This boosts thrust with little increase in cavitation. These special propellers allow the ship's passengers and crew to enjoy both a fast and quiet ride. In this giant foundry, engineers forge propeller blades from an aluminum-bronze alloy. Robots cut and polish the cooled metal according to a precise computer design to shape the 5 blades.
We usually make each blade in an independent way because the blade's geometry is very complex, which make the manufacture also complex.
The individual blades fit into a central hub to create a giant 20-foot diameter propeller weighing over 33 tons. Bellissima's 2 propellers attached to a pair of mounts on the ship's stern. Thanks to Loic and his team, Bellissima's propellers are among the quietest installed on any operational cruise ship. The guests on board sleep peacefully as the ship sails towards Marseille.
During early morning, as you can see that the corridor is very quiet and you don't hear any noise. All our guests are sleeping well, so I'm so happy with this one.
At 8 a.m., Bellissima pulls into Marseille right on schedule. The passengers take in all the sights and sounds of the famous French city before returning to the vessel 8 hours later. At 6 p.m., the ship sets sail for Genoa, Italy. Ahead lies a huge challenge for the ship's crew. They must keep over 5,600 passengers fed while navigating through over 1,200 miles of turbulent seas. What engineering secret helps this megaship stay stable in the roughest waters? And what technology allows it to produce fresh water on demand?
Perfect.
It's day 3 of MSC Bellissima's 8-day voyage around the Mediterranean. At 8 a.m., the mighty cruise ship docks at the Italian port city of Genoa. Here, the crew loads 420 tons of provisions into the ship's 21 giant storerooms below deck. The supplies include 9 tons of flour, 15 tons of meat, and over 22 tons of fresh fruit. Enough to keep the passengers and crew fed for the remainder of the voyage. But this ship's lifeblood is fresh water. Together, the ship's passengers, crew, and all its processes consume over 3 million gallons of water during a typical 8-day voyage. Supplying this much fresh water is a huge engineering challenge. To make things even more complicated, room on board the ship is at a premium. Cabins and entertainment areas take up 74% of the space on board. The engineering department and guest service occupy an additional 23%. And the vessel's fuel, ballast, and waste tanks another 2%. That leaves enough space to carry just over 1 million gallons of water. Less than half of what Bellissima needs to run systems and supply its 7,000 passengers and crew for their 8-day voyage. At the shipyard, engineers deploy an innovative technology to make sure Bellissima and its sister ships never run out of fresh water. Project manager Antoine Gondet oversees the operation.
If you don't have enough fresh water on board, then it can very, very quickly turn into a drama and you are forced to stop the cruise.
Hidden deep inside Bellissima is an ingenious system that turns over 250,000 gallons of seawater into fresh water each day. Pumps suck seawater into the ship through pipes in its hull. Layers of sand and special carbon filter out the largest pieces of debris. Next, filters remove microscopic contaminants 50 times smaller than a human hair. Then, the water passes through columns, each containing a spiral of molecular membranes. The superfine membrane weave separates salt chloride ions from water molecules. Once free of salt, this fresh water is ready to use on board. The process converts almost 3 gallons of water per second when the ship is at sea.
Because the cruise ship is spending half its time at sea, these plants have a huge production capacity to fulfill the needs of the vessel within half a day.
At the end of day 3 of the cruise, the megaship departs Genoa and heads out into open sea. This is when the water plant kicks into action. Powerful pumps pressurize the fresh water and push it through dozens of miles of plumbing woven throughout the ship. 20 giant tanks each hold up to 66,000 gallons of the desalinated water. This liquid must pass through one last process before it's fit for passengers to drink. Vice President of Environmental Operations and Compliance, Minas Mirtides, must ensure the system works without a hitch.
The final part is where we add the chlorination and where we manipulate the pH level of the water so we have absolutely crystal clear, perfectly tasty, good, fresh water. Look at that.
Yeah.
Nice MSC Bellissima produced water. Salute. Perfect. Very good.
It's the morning of day 4 of Bellissima's cruise. The megaship docks at Naples. Passengers disembark to visit the famous Roman ruins of Pompeii. They return to the vessel 6 hours later. The megaship leaves port en route to Messina on the island of Sicily. But new challenges lie ahead. Strong Sirocco winds can make this part of the journey very bumpy for the passengers and crew. What ingenious technology keeps this megaship stable in the roughest seas? And what is its secret for producing some of the cleanest emissions of any ship in its class? It's dinner time on day 4 of MSC Bellissima's 8-day Mediterranean cruise. Thousands of passengers enjoy meals in one of the ship's 4 huge restaurants. Maitre d' Vincenzo Porzio must make sure every diner receives 5-star service.
The peak hour is start from 8:30 until 11 o'clock. We serve already, I think, 10,000 meals.
But running a restaurant at sea has its challenges. Sudden changes in weather can make this stretch of water rough and cause the ship to pitch and roll. Choppy seas make any ship move from side to side, risking spills and even injuries.
It's not easy to work with the rolling of the ship.
And if the ship encounters a big squall, the effects on board can be devastating. The higher a ship floats in the water, the greater the effect can be of violent movements caused by rough seas. Bellissima's towering 213-foot height makes it vulnerable to a phenomenon called parametric rolling. Large, regularly timed waves hitting the ship head-on make the vessel seesaw. When a large wave reaches the back of the vessel, it makes the ship tip forward. The way the weight is distributed across a ship this tall can then cause the vessel to roll to one side. When the next wave hits, it rolls back the other way. Each new movement is more extreme than the last and can cause passengers to become seasick. At the shipyard where Bellissima was constructed, engineers worked to solve the problem. First, they identified the specific type of ship movement that causes passenger sickness.
We are more sensitive to the rolling motions than pitching motions. As soon as you have a very big ship is reacting faster to the waves. So in a sense, you will get higher accelerations, more like pong pong. Higher the accelerations you get, and better chance you get to be seasick.
To minimize this rolling motion, engineers installed a pair of fin-shaped stabilizers into the vessel's hull. The stabilizers arrived at the shipyard, ready to plug into holes cut into the ship's hull. Hydraulic pistons moved their articulated wing-shaped fins, measuring 18.4 feet long by 8.2 feet wide. These stabilizers are Bellissima's secret to smooth sailing in all weather. Sensors on each stabilizer measure the direction and degree of the ship's roll. If the motion goes past just 1 degree, Bellissima's crew can deploy the pair of stabilizer fins stowed inside its hull. The fins work like wings to correct the ship's roll. If the sensors detect the ship rolling starboard, they automatically instruct the fins to rotate, shifting the vessel the other way. In big seas, the system works continuously to level out the rolling motion, ensuring Bellissima's passengers and crew experience a smooth ride. Up on the ship's bridge, officers monitoring the weather give the order to activate the stabilizers. Chief Engineer Luigi De Martino makes sure they deploy without a hitch. A pair of 5.2-foot-long pistons turn bearings that swing each fin into position. A computer automatically adjusts the angle of the fins to counteract any roll caused by waves hitting the ship.
In the bad weather condition, they're moving up to 16 degrees. 16 is the maximum angle allowed for a free stabilizer.
Each fin is just 13% the width of Bellissima's hull, but their combined effect on the ship is huge.
This system can reduce up to 90% of the rolling motion of the ship. Now it's really impressive. The passengers are very glad to be on this ship because it's comfortable for everyone.
With the stabilizers deployed, Vincenzo's team is able to wait on every table without danger of being thrown off balance.
It's fantastic. It's amazing ship. We have the top technology of the world.
Bellissima arrives at Messina on the morning of day 5 of the cruise. After a 10-hour stay in Sicily, it will power onwards to Malta. And this megaship will face new engineering challenges. What innovative technology keeps the air around the outside decks free from noxious exhaust gases? And what's the secret to maneuvering this Leviathan into the tightest ports? "8 a.m., day 6 of MSC Bellissima's 8-day tour of the Mediterranean. The mighty cruise ship docks at Valletta, the capital of the island of Malta. While many passengers disembark to explore the winding streets of the old city, some remain on the ship to relax on the sun deck or take the plunge in the vessel's water park. Pool supervisor Alonzo Stewart is on site to ensure nothing ruins the guests' outdoor experience.
Here we can have 600, maybe 700 passengers per day going around at the aqua park. It's a lot of people to keep happy, but the passengers come here to take fresh air. That's the important part.
Guaranteeing good air quality across a cruise ship's outside spaces is a tough challenge. The ship needs a reliable source of power to run all its essential systems and provide all passengers on board with a constant stream of electricity. Bellissima's 4 diesel-electric motors work around the clock. At peak output, they produce 67 megawatts of electricity. enough to power 50,000 homes. But burning heavy fuel oil produces exhaust gases. Many cruise ships vent these fumes from funnels positioned above the top deck. On Bellissima, these outlets are just a few feet above the ship's popular water park. So engineers have to make sure guests don't breathe in harmful gases. Classic liners solve the problem with long exhaust funnels that release dirty, sulfurous fumes high above the top deck. Bellissima's uppermost public space is over 180 feet high, nearly double the height of a classic liner, and it's around 33 feet away from the ship's exhaust outlet. Simply making Bellissima's funnels longer will create a big problem when the megaship enters ports spanned by low bridge decks. At the shipyard, workers race to finish building Bellissima's sister ship, MSC Virtuosa. A giant equipment install reveals both ships' secret to beating harmful fumes. A pair of huge steel drums 16 feet in diameter and over 33 feet tall, each weighing 22 tons. These steel drums, called scrubbers, remove almost all of the environmentally damaging sulfur compounds from the engine's waste gases as they move through the exhaust system.
The sulfur is really dangerous for health, but such machine like scrubber is able to very efficiently remove it, so we don't have to breathe it.
Nozzles inside a scrubber's drum spray nearly 6,000 gallons of seawater per minute into beds packed with metal filings. Engine exhaust gases rise through the moist beds. Pollutants dissolve into the water. Water droplets trickle down the inside of the drum and collect in a treatment chamber. Here, a chemical process separates the clean water from pollutant, and the waste forms a sludge. Experts responsibly dispose of this waste on land when the ship is in port. Bellissima departs Valletta and powers forward into open water toward its final stop, Barcelona. The scrubbers kick into high gear to clean waste gases ejected by the ship's 4 giant diesel-electric motors.
The system has the ability to remove 97% of the sulfur dioxide that is contained into the exhaust gas. And that sulfur, it never goes on the air, never goes in the sea, and then it is removed when we are in port.
On the top deck, guests are busy racing down the water slides or working on their tans, oblivious to the ingenious technology working in the background.
We start this morning full from the first moment until the end. Today, the air is very nice. The passenger enjoy the slides 100%.
750 miles of open sea lie between the vessel and Barcelona. Will this giant ship arrive on schedule? And what is its secret for docking in the narrowest, busiest ports? In the Mediterranean, cruise ship MSC Bellissima closes in on Barcelona. The port city is the last stop on the mighty vessel's 8-day, 1,864-mile journey. Captain Raffaele Pontecorvo and his officers will have to reverse the vessel over a mile down this narrow channel to reach the busy harbor. Parking backwards means the ship will be facing the right way for a fast departure later this afternoon. But guiding the ship to its berth is a huge challenge. The vessel's tall profile makes it vulnerable to high winds, blowing it off course. One wrong move during the reversing maneuver, and it could collide with another mega ship.
We have always to take care about the wind. It's really a big responsibility, taking in mind that you are the only responsible for the life of more than 7,000 people.
Bellissima relies on a responsive steering system to help guide it through narrow channels in all weather conditions. At the shipyard in France where Bellissima was built, engineers prepare to install a sister ship's propulsion system. A pair of 20 megawatt electric motors in waterproof housings called podded thrusters. Unlike fixed propeller propulsion systems, these pods swivel their propellers to direct thrust precisely where it's needed.
For this very big cruise ship, we prefer to use the pod. So all this unit can move 360 degrees, so that makes the maneuvering much easier, much faster, and which allows to the captain to be able to park the ship into the very complex harbor.
Bellissima carries a pair of podded thrusters at the rear. 4 fixed thrusters in the bow direct powerful jets of high-velocity water to help steer the ship from the front. Together, they make this huge vessel highly nimble. Outside Barcelona,
we have a ship on port and starboard side, and we take care of the distance from port and starboard, because we have around 50 meters one side and 30-40 meters another side.
Pasquale relays readings from this laser measurer to track the distance between Bellissima and the moored megaships.
Distance from the bow to the aft.
Yes, at the moment 100.
Okay, we push a little bit more the bow to port.
Bellissima's berth comes into view.
Forward 40 meters.
Captain Raffaelli turns the rear thrusters and pulses the bow thrusters to delicately maneuver the 1,034-foot-long ship alongside the quay.
Okay, okay.
Okay, we are in position, we proceed alongside. Okay, finish with the engine. Okay, thank you, staff.
The megaship completes its 8-day, 1,864-mile voyage right on schedule.
The weather was nice. There was not more than 4 knots wind, good visibility. It was really good. It was fantastic.
Passengers disembarked to return home after their Mediterranean adventure.
It's nice for the guests. They are very happy on board, and they are upset when they are leaving it. So it means they really enjoy the vessel.
MSC Bellissima is one of the most innovative mega cruise ships in the world. Built into its mighty structure is a series of engineering marvels that make this ship the pinnacle of passenger vessel design. A wide hull and small draft allows it to slide into the shallowest ports. Extra quiet propellers drive the ship without disturbing the guests. An ingenious water plant turns the salty sea into crystal clear drinking water. Fin stabilizers keep the ship steady in the roughest weather. Exhaust scrubbers clean waste gases and reduce noxious emissions. This giant passenger vessel is one of the world's biggest cruise ships. MSC Bellissima, is built